Hello friends, my name is Shubham Chaudhary and this is my second project. Sorry, this is my fourth project and it is given by the Spark Foundation. So we discuss it. What we do, we taken out the data set from a Kaggle and that data set is global terrorism and it is used for EDA analysis. Means that we find out the uh, attacks are increases. We know that attacks are increases day by day. Some terrorism activities are involved behind the attack. So we find out in this data set the rate of attacks are increases between 1970 to 2017, and also we find out the number of attacks happening in a country or that number of a that also find out with the help of this data set. So let's start. First, we import the important libraries such as the pandas, numpy, matplotlib, and seaborn and plotly. Okay, so plotly here we use for a extensive version of a matplotlib library. Okay, and after that we upload the data set, and that data set is present in our D library. So we import the data from my D library. Okay, it is global terrorism and it is in the form of a CSV file. So we, with the help of a pandas library, we read this file and then this is our data set and we can see that this is a large data set and we have a lot of null value in this data set and all we find out the also we find out the which columns are uh, used for analysis and which are not used for analysis because this is a large data set. So first we find out the none and none values and duplicate values, and we find after that we do some pre-processing in this data set. Okay, so the shape of this data set is around 1,81,691 and we have 135 columns, means that we have a 135 features, and here we can see that all the in 135 features, uh, only some features are important for analysis. So what we do, we eliminate all the unimportant or unnecessary columns uh, in this data set. So we drop out, or we can say that we eliminate all these columns which are for not for use for analysis. So what we do, what we find out the unique value in this data set. Okay? So we have a 47 unique value in a I year and 13 in a I month, and in a day we have a 32. Means that we have a lot of a duplicate value in this data set. So and we find out the null values in this data set, and also we have a lot of null values in this data set. So what we do, we here we can drop all those columns which have not used in the analysis of a global terrorism. So we eliminate all those columns. Okay, so now the shape of our data set is 1,81,691 and 30 columns, and above we have a 135 columns. So it's just one fourth row, one fourth column we use for the analysis. Okay, and this is our data set, new data set. Okay, this is df1. Now we define the new data set in a histogram. Okay, In a histogram, we show that relationship between year, month, I day, country, and number of attacks is around 20,000, 47, 1400 and 1600. Okay. In a month is also 10, 20, and this is define a relationship. Okay. And now we use uh, here what we do, just we find out the uh, relationship between the count, mean, standard mean, minimum value in a data set, maximum value in a each uh, features, or we can say that in a each column. So what we do the use for a describe command for the analysis, and here count it means that number of a data set. So we have a 1,81,691 number of rows, and mean of this data set, average mean we can say that is 202, and standard deviation is 13, and minimum value is this, and 25 percentile, 50 percentile, 75%, maximum value of this. So what we do, each feature define in terms of a count, mean, standard deviation, minimum and max value. Okay, reason, latitude, attack type, target, weapon type, and kill, and round, eye shot, and shot. Okay, okay, okay. This is describe is for only a numerical data type, not for a categorical data type. Okay, it represent only a numerical data type. Now we use for we find out the correlation uh, between the variables or the features, and here we find out the uh, relationship between the feature. Here we find out the 0.6 is a good relationship between the attack type and the attack type and the weapon type. So it has a good relationship between us, means that the data uh, is dependent of these columns with each other. Okay, then find out the number of attack rate which are successful in or not in a year. Means that we find out the uh, uh, number of attacks in a year, it is successful or not. So what we do, we use a count float for this, and in a X we define a year, and here it is used for success, and data is df1. Okay, and title we use increased terrorism from 1972 to 2017, and here we can see that the terrorism is increases as the year is increases, and around 2014 the terror attack rate is more than any other years. Okay, and success rate is very high in 2014. Okay, and also around 2016 the unsuccess rate of the attack is high in this year. Okay, so we find out the uh, attack rate in terms of a year. Okay, now what we do next is we find out the how many attacks were there in 1972 2070, and it is find out in the form of a percentage, means that uh, we find out the ratio between 1972 to 2070. Okay, so what we do, we just calculate the total year value, and this year value is subtract from 2005 1917 and find out the rate. And then year is 1970 and attack happened in 1970 and year is 2017. Okay, so we find a 651 attacks happened in 1970 and then around 10,900 attacks happened in 2017 and rate of a percentage is 94%. It means that it is too high percentage. Means that the attack is increases very fast. Okay. Now we next what we do, we find out the successful and unsuccessful attacks, okay, globally. So here we can see that the success rate of attacks globally is very high. In, it is near about 1,60,000. So it is very high. And successful rate is successful, and this is from 1970 to 2017. Okay, this is a distribution club, distribution plot. And after that, what we do, we define all the data set in the form of a suicide attack and show how many are successful and how many were not. So we use a in this we use a country and group name and a corporation and weapon time which is used uh, for terror attacks. So here we use a cross tab and we just here we also use a pivot table for combining the data set, and here we use a df1 dot country test. Okay, first we define in terms of a country. Suppose that is a country test, and then df dot site we use a site in terms 0 and 1 gives the 0 is success and 0 means that zero means it is uh, suicide or a not, one is it is suicide. Okay, and then df dot success means, and third is use success 0 and 1 and total value here we use. Okay, so here we find out the uh, suicide attacks and how many are successful and which are not. So here we find out the suicide. If suicide attack is 0, the total number is 11,503. Mm, if it is suicidal, sorry, if it is uh, success mean if it is suicidal, so it is not suicidal, so case is uh, around 1228. Okay, so now we use define suicide attack mm, with the group name. So here we define a group name and with the size and df dot success and margin and then total. Okay, so we have a total number of zero success is around 20k and 1 lakh to 61,000 is success attack and totally this is the number of our total data set. Okay, now we use a uh, now here we use a corporation means that the designation of a target corporation. So it is defined in terms of a society with the help of a success, it is success or not and all. Okay, it is show that which type of a weapon is used. Here also define a weapon is used, it is biological, chemical or explosive and it is suicidal or not and success rate it is same as the above. Okay, then here we use a ps dot scatter diagram and here we use a in this data set we find out the these bubbles shows each country in our data set uh, and with It is represented with the years, casualties, death, and success. Okay, here we define as a DF one dataset and DF dot n bound use, DF dot n kill use, and hover no hover name is country text. Okay, hover name is country text. Basically, it is a command, so it is just command. So we use here we define the four uh, four parameter in it, such as a year, casualty, date, and a success with the name of a country. So country test, hover name is the country test, means that hover name is the country test means Democratic Republic of the Congo, and animation frame is yearly wise, means that it is from 1970 to 2016, and size is success, it is size of a success, and size of bubbles is 40, range of color is between 0 and a 1, and labels here we use and kill deaths and mount and not casualties as we define in the data set, and title is number of casualties versus killed people in each country for each year. Okay, so here and kill is defined by a and kill means number of killing people means is a death. So here we define a death. Okay, labels is defined by and death. Okay, and one means a casualty means that some persons are not dead. They have some injury. They got some injury in an attack. So this is number of wounded people. So it is the casualties and death, number of death. Here we define. Okay, death and a success. Size is success. So it is defined as success one or zero. And we start this graph. So we start from the beginning. Okay, here number of here is the number of casualties. Here is number of that. Okay, and then start the diagram, and here we can see that year uh, year increases and number of attacks with each country is increases. So just we just pause the graph, and here we find out around 2000, sorry, just 2004. Here we find out Ethiopia. Year is 2004 and casualties around 13, and that is 0. And Honduras is year is 2040, casualties is 14 and 30, 28, and success is 1. Okay, so it is a this graph is used for number of casualties and kill people in each country uh, for every year in a terror attack. Okay, now we find out the total number of attack in each country with the help of a globe. Okay, so what we do, we just use a country text, and uh, another uh, another important library we explore, plotting library we use again, and projection here we means that this is a globe, so projection means that with orthographic. So here we use orthographic, and title is total number of attacks from 1970 to 17, and label is higher in terms of attack. Okay, so this is a candle of attacks and showing with a lot of colors, and here it is shows if the terrorist number or total number of attack is increases, the color of the bar is changes. So here we can see that if we move the globe, the South Iraq has a lot has number of attacks rather than any country. So means that uh, it is a more dangerous city for living a people. Okay, safest country here we find out that which is in blue color. Okay, yeah, which is in blue color. So this is the Democratic Republic of the Congo. The attack is around 775 in a year 1972 2070. So it is a very less uh, number. It is a very less number. So we can see that it is a good country uh, for the uh, living people. Okay, now just go the downside. Here we use a world graph, and you can see that here we cannot use projection like this orthographic. Here is only use a command, and here we just use a location country names, and color is I here, and title is number of attack. Okay, it is just same like we described above, but here we use a world graph, and in above we use a globe. Okay, now we find here now here we find out the maximum value of a year, and we find the IDX maximum is all the important parameters in this year. We find all the parameters, and then maximum name find out in a country txt. Same for count, IER minimum value, IDX, all the minimum values find in a year, and country test minimum ID. Here we find out the which country suffered the maximum number of attacks and which country suffered the minimum attacks. So means that which country is safest for the people and which country is not safest for the people. So here we find out that Iraq has the maximum number of attacks rather than the other country. It has 20 around 24K attack number of attacks, and Andorra has a minimum number of a terror attack, means that it has safest city for living people. So this is our um, project number 4. I hope you like this. If you like this, please hit the bell icon, and please subscribe my channel. Thank you.